Hello everyone, welcome back to PMAT1100. In this video, I will be talking about section 2.1. We continue with unit 2 in the textbook. In this section, we'll be talking about some terminology, some vocabulary that you use for you. It helps you to be able to understand math textbook, because math is like a language, right? So in order to understand a language, you need to know a lot of vocabulary. So as long as you know a lot of vocabulary, you can understand that language. So it's the same in mathematics. In order to understand mathematics, you need to know a lot of math vocabulary, okay? Or I can say the math terminology. So there's some terms, some terminology you need to understand in this video. So let's get started, okay? Alright, so I'm gonna put over here section 2.2. Okay. The first terminology you see very often in all different branch of mathematics. It is constant. Constant. What is constant? Constant is just a number, just number. For example, like 2, 3, 4, 5, 6. So constant is number, okay? Something that does not change. Constant, it's fixed, okay? The second one, so I'm gonna put over here, but the second one is variable. Variable. And there are two types of variable. We have dependent variable and independent variable. Okay. Variable is something changing. This is a quantity that is able to change or vary. So I'm going to add over here is quantity that is able to change or vary. Usually in mathematics, we use letter X to represent variable, okay? So you can use variable X or Y or Z, okay? Then what is dependent variable? I mean, when you read it, you know right away. Dependent variable, I mean, it's a quantity that is dependent on another quantity. It's dependent, okay? And independent variable is a variable that is not dependent on another quantity. So so if a quantity depends on another quantity, then we say it's dependent variable. If a quantity does not depend on another quantity, then it's independent variable. I can give you example like this. So example. What if I say like this? The number of miles you travel. I can say like this. The further, okay, the further you travel, or you can, let's how about like this. I'm going to erase this. The more gasoline you have in the tank, the further you travel. Okay, so which one is dependent variable, which one is independent? So the more gasoline you have in the tank, the further you travel. The further you travel, it means the number of miles, right? Over here it means the number of miles you travel, right? The number of miles you travel. So we gotta see which one. We over here we have two variables. We have the number of gasoline. So over here is the number of gasoline. I'm sorry, the amount of gasoline. The amount of gasoline. The amount of gas. And over here is the number of miles. So this is the two variable here. This is two variable here. And I can name this variable over here, and most of the time is they use letter X for independent variable, and letter Y is dependent variable. Okay, so X is independent and Y is dependent. Okay, most of the time they use like that. Well, you can name any letter. You can use any letter you want, but most of the time it's X and Y. So X is independent variable and Y is dependent variable. Okay, so we have to see over here which one is X and which one is Y. So the number of miles you travel, it depends on the amount of gas. Right, so I can say I'm sure that I know that over here this is because the number of miles you travel depends on, so this is Y right here, right, and this is X right here. This is X right, because this is independent. This is depends on the Y depends on the X, right, because Y is the number of miles you travel. It depends on the amount of gas. Okay, it depends on the amount of gas. All right. Okay, the more gas you have, the further you can travel. Okay, that's one of the example. I can give you another example. Example 2. I can say like this. There's a lot of relation you can find. Okay, how about this? The more problems you practice, the better your performance is. Okay, so the better the performance depends on the number of problems you practice, right? So let me use a different color over here, right? Let me see, I can have another color here. Okay, let me use this one. Okay, all right. So the problem you practice over here, the number of problems, okay, and over here is your performance. So your performance depends on the number of problems you practice. So your performance is dependence variable. So your performance will be y, right? And this is the independent variable. So this will be x. Okay. Let me put this down there. So that's, you see that there's so many relation you can have. You can have between dependent and independent variable. Let's see, I can give you another example or not. Oh, I think 2 examples is good. Oh, let's start with another one. If you can. Oh, so let me go back to this color. Example 3. Let me think of another example so that you can see the relation between dependent and independent. I mean, most of the time they use x and y in mathematics, but I mean, it could be anything. It could be z and this would be w. It's just the letter. It's just the name. You can name everything you want. Okay. How about this? Okay. How about the age? How about the age of a tree and the height of the tree? Okay. So which one is variable independent? Which one is dependent? So the age of the tree, I mean, the older it grows, the higher it becomes, right? The higher the tree will be, right? So the older it's growing, the more it's growing, the higher the tree is growing. Okay, the higher it will be. Okay, all right. So I can say that this is what variable? Okay, this is what variable? The age of the tree and the height of the tree. So the height, it depends on the age. So I can say this is independent, right? This is independent. So this is independent. Over here is independent variable, and this one will be dependent variable. Right? Because it depends on this. It depends on the age, you know, like this depends on the age, right? You can tell it right away. All right. Just so that is one of the relation I can give you. All right. So we talk about variable, we talk about constant. That is 2 terminology you need to know every time you learn mathematics. The 3rd terminology I want you to know, it is algebraic expression. So algebraic expression is a math expression, mathematical expression. It's a mathematical expression. Okay. So what is expression? What is mathematical expression? It is combination. It is combination of variable and operation. Operation, it could be all the operation you already learned in elementary, like plus, minus, multiplication or division. Okay, if you you in high level, you can do exponent. Okay, exponent. Okay, or maybe radical. Okay, there's more and more. Okay, all right. I can give you example of what expression look like, because it's this combination of variables, so it means it's a combination of a number and letter, right? And it could be any letters you want, X and Y, T, whatever it is. So example, this is algebraic expression. So this is expression. For example, I have 2x. 2x is expression, or I can have 2x you add it to a number, or I can have 3x added to or subtract to, or let me use subtraction, minus 2y plus w. This is all mathematical expression. Okay, or it could be something with like 2x squared over x plus 1. This is also mathematical expression. This is a very special mathematical expression. This is sometimes we call rational expression, because this is there's a fractional bar right here. So this is we call it rational expression. But this is also expression. They all expression. Okay, they all mathematical expression. Or we can use a square root, or can use something like a square root of 2 plus 3x. This is also mathematical expression. So they all expression. Because we use a square root, so we can call it radical expression. So this is a radical expression. Okay, radical expression. All right. So that is what expression look like. Okay. Another terminology you need to know, and you see very often in all the textbook, especially in college algebra, it is equation. What is equation? What is equation? What if I have something like, what if I have two expression like 3x minus 1 and 4x plus 3. So I have two expressions like this, and between these two expressions I put the equal sign. I put an equal sign. So what I just do, I just create an equation. Okay, so this is the equation. So equation is actually a statement. A statement according to our textbook. Consider that two quantity are equal. That two quantity are equal. Okay, so this is first quantity, this is second quantity. So this first quantity here, and over here is the second quantity. Okay, so they equal to each other. They equal to each other. I need to pull it out. Okay, they equal to each other. Okay. and this quantity here is built by the expression. So this is expression, this is expression, right? So you have two quantity, then you have equation equal to each other, then you have equation. If it's not equal to each other, then we call it inequality. So I'm gonna just provide you another terminology here, but in this course we not doing that. We're not covering that, but I just want to add you, I give you some an extra terminology for you to learn. So if, so I'm going to use different color. Let's use this one. Let's use this one. Okay. If one quantity is not equal to the other quantity, then we call inequality. So this is one of the terminology I want you to know, inequality. Okay, I'm not going to that deeply, but it's good if you know another terminology. Okay, and the last terminology I want you to know in this course is formula. What is formula? Actually, formula is an equation. It is equation, but with many variables. So I can say the formula here, okay, is an equation with multiple variable. Okay, and that is used. It is used. Okay, it's used. Okay, it's used to calculate. Oops. Calculate a quantity. Okay. For example, maybe, wow, I'm sure that everybody know what formula is. You know, the first time sixth grade, when you already learned the formula of finding circumference, right? Of finding area of the circle. So you can, I can give you the example of the circumference of the circle be 2 pi r. So this is a formula. Okay, C represent the circumference, right? R represent radius, pi is 3.14. Everybody know this. Or we have another formula like A equal to pi r squared. This is area of the circle. So this is a very simple formula, and you see this is an equation because this is one of the quantity here, and this is another quantity, and these two quantity equal to each other. So a formula is an equation. Okay. All right. Let's get back to our first, maybe the first thing, maybe I forgot to tell you, dependent variable, we have another name. We also call the output value. Okay, and this is input value. X is input value. So it's good if you know output and inputs. Every time we talk about output and input, you talk about X and Y. Okay, but again, X and Y, it's just the name. It's just the name. So you can name any name you want. You know, you can use any letter to represent dependent or independent variable. Okay. All right. So those are formula I want you to know in this section. A, B, C, D, E. So there's only 5 of them. I provide you more with the input and output. I provide you with inequality, which is we not covering in this section, but later on it's very helpful for you. Okay, it's good to know more. All right. Okay. So let's do one of the example, our application using this terminology. Okay, let's see what we have here. I think I'm gonna use one of the text we had, or maybe we do one of the problem is provided in the text. Let's see. Oh, okay. Okay, let me see. Okay. Before do that, let's talk about evaluation of expression. How to evaluate an expression given an input value. So let's do that. So in part F. So in part F over here is not a terminology, but I just included here. So part F, evaluation of expression. It means what? When you evaluate, what does it mean? It means that you have an expression. It means that you have an expression, and we want to evaluate that expression. What if I have expression like this? So evaluation, it means that you calculating. It means that you calculating that expression given a certain input or given a certain x value. Okay, that x value is equal to the constant. What if I have expression like this? What if I have like 4x minus 3? This is very typical expression, and I want you to evaluate, okay, the expression above. Okay, expression above. Oops, I don't have more paper. Expression above with, let me finish it, with x equal 2. So how we do that? It means that you're gonna put 2 over into the x. You're gonna replace that because x equal 2. So you're gonna replace the x here with 2. So my expression become what? It become 4 2, right? So instead of having x, we're gonna put 2 there. So replace the x with 2 minus 3. Okay. Then over here we're gonna do 4 times 2 will be 8. And minus 3 will be 5. So that is how you evaluate. Okay. That's what it means by evaluation. Okay. But on the test, I don't think I'm going to give you some problem data. The reason I give you this question because I just want you to understand the term evaluation. What does it mean by evaluation? But in order to really evaluate it, you need to know PEMDAS rule. So in this course, so far we have not covered PEMDAS rule. So I don't think that I'm going to put this on the test. Okay, but it's good to know that what evaluation means. What evaluating. Evaluating, it means that you replace the act with a number and you plug it in. Okay. So in order to evaluate, you need to know PEMDAS rule. It means you do multiplication before addition and subtraction, something like that. Okay. All right. All right. So let's jump to one of the example, practical example with data, so that we with equation and data, and see if you really understand the question of the problem or not. Okay. Let's see. Okay. Page title. Okay. So the application we do for our concept today will be about simple interest. Simple interest is the when we already learned in previous section. However, at that time we never cover the formula, because you don't know what formula means. But after we learn this, you already know what formula is. So we're gonna try to use formula to calculate simple interest. Okay. So let's start with our application. Okay, and we're gonna do simple interest. Then we're gonna use okay, I think we're gonna do simple interest, and we do a compound interest because there's both of them, but I don't think I have enough time to cover compound interest. However, I will provide you the formula for both case, simple interest and compound interest. Okay, let me use this color right here. So simple interest, formula, and I will explain what does it mean in those formula. I mean each variable. So the formula is A equal P plus PRT. So P in this case is the original amount. So P is original amount. Okay. A is the new value of account. So the new amount. A is new amount. A is new amount, and R is the rate. Okay, interest rate. Okay, R interest rate, and T is time. Mostly it's year. Most of the time it's year, or could be hour, but I think I'm going to use year. Yeah, let's do year. I mean, but it could be anything. It could be hour, but I mean hour is not really practical, so it should be a year or month only. Okay, years or month. Okay. All right. And for the compound interest, so I'm gonna write on this side. The compound interest. Let's box this formula. Okay, and for the compound interest formula, we already know and we already learned the difference between two type of interest already, but so I'm not gonna repeat that. However, at that time we don't know the formula, so the formula is we're covering right now. The compound interest formula will be A equal P 1 plus R, and everything raised to the t power. Everything raised to the t power. Okay. So A in this case again is still a reasonable amount. A is a new amount. R is the interest rate in the decimal form, of course, because it's the rate. For example, like 3%, like over here I'm gonna put in percentage, and you know, every time we have percentage you divide by 100, right? And that's why, excuse me, and that's why we have a decimal number. And t is still in t is still a number of years. Okay, t is the number of year, number yeah, it's number of year or number of month. If they give you month, but if they don't say anything, most of the time it's year. Okay, so everything the same. All right, now I will I'm gonna do an example on simple interest only. Maybe on the test I'm gonna ask you the compound interest. It's just the same, you know, so just plug in the formula, you know. All right. What if I have something like this? Example. So let me go back to our example. If you start with 2,000 in account, okay, with $2,000 in account, it doesn't matter what account, you know, and earn 3% simple interest, 3% simple interest each year. Okay. The first question is, okay, A, how much interest would you earn each year? How much interest? Or the question could be how much money can you earn from that interest each year? How much money you earn from that interest, okay, each year. Okay, they can ask you like how much interest you earn each year, but I think that type of question is kind of confusing. How much interest? It's like they asking you for interest. So I changed a little bit the question: how much money you earn from that interest each year? So the answer is very simple. Okay. Let me use different color for the answer. So we have application. So let's use this color. Let's see what's going on here. So this is 3% interest. So in order to get the amount of money for each year from this 3%, 3% is 0.03. So you just do 2,000. Look like this color doesn't work. Let me use another color. Let's see. I think we're going to use this one. No, I'm going to use this one. How about this one? This one work, huh? This one beautiful too. I think I'm going to use this one. Okay. So we're gonna take 2,000. You multiply by 3%, 0.03. So the answer will be $3,000. The answer will be you put into calculator. The answer should be $60. So it means that every year it's $60 you earn from that interest. Okay. Now question B. Question B. Okay. Now, if we know the original amount already, right? We know percent. We can set up the formula for this simple interest, and we're gonna use this formula. So, question next is setting up formula. Okay, let me move this. Oops. Okay. So the formula we already know. So we know everything. So A should be equal to P is the original amount. So it's 2,000 plus another 2,000. Time R is 0.03 and time T. Okay, and this is equal to 2,000 plus 2,000 times 0.03. We already calculate here, which is 60 T. There you go. All right. Now for question C. For question C. Let's see. Question C. They give us the table. And this table gives us it tell you the number of years for they put money in the account. So they give you the table like this. Let me move it down. So they give you the table like this. And over here is T. Okay. Over here is the formula. Okay, and t from 0, 1, 2, 3, 4, 5, and 6. So they want us to fill up this table. So at t equals 0, actually it's, initially we have only 2000. It makes sense because when you plug 0 over here, 60 times 0 is 0. So the only amount we have is 2000, right? Oh, I think I'm gonna use the different color. So it's originally we have $2,000. Then after the first year, we plug it in. So I'm gonna do on the side here. So after the first year, so A will be 2000 plus 60 times 1, because it's the first year, you replace t with 1. So 60 times 1 is 60. 2000 plus 60 will be 2060. Okay, and you do similarly for all the t. Then you have this is will be 2120 after 2 years, and after 3 years will be 2180, and after 4 years will be 2240, and after 5 years will be $2,300, and after 6 years will be 2360. It means what? It means that after 6 years you will earn $2,360. So it's 360 more compared to the original amount you put it in. It is $2,000 only. So you make some kind of money, you know. I don't know what type of bank give you this interest, because 3% is kind of a lot. So it's still a good deal. You know, it's still a good deal. Okay? Very good investment. All right. Now next question. CD. See the value. What is the value of the account after 2 years? Here you go. What is the value of account after 2 years? And we already calculate in the table. So after 2 years will be $2,120. So we can answer really fast. And you can answer all similar question based on this table. Okay. All right. Let's see any other question they can come up. Because based on one question, I can based on the data, based on the information, I can come up with different type of question. So let's see. Actually, I already told you like the amount of money earned after 6 years already. So yeah, I think that's all. I think that's all. And you can do similarly for the compound for the. I'm sorry. Oops. Oh, I'm sorry. For the compound interest, you can do the same. Okay. You can do the same for the compound interest. If they asking you the same type of question, you just plug it in. But for the compound interest, you have to raise to the t. What if t is 2u raised to the second power? Yeah, you guys have calculator, so it won't be hard. Okay, so I think I'm gonna stop our lesson 2.2 right here, and go ahead and go through all the example. If you don't get it, please send me a Canva message. I will try to reply to you as soon as I can. Okay, otherwise I'll see you next time. Bye bye.